Okay, excellent. So let's begin our class now. So we have 80 minutes and we will try to cover as much as possible. So first of all, I will explain key points to you and then we will do some questions from past papers. Okay, so first thing we need to understand about electricity. So there are few points we need to understand. So if any one of you is not clear, so this is kind of review. So the first thing we need to understand is that about circuit. So let's start from circuit. Two types of circuit we will discuss. So the one is series, the other one is parallel circuit. Okay, for series circuit is very simple thing we understand, but often students get confused actually. So you have to be quite clear about this one. For example, if I connect some resistors like this here, so let's say we have these few resistors. If we connect them, so let's say we have resistor R1 and let's say this is equal to 10 ohm. We have resistor 2 and this is also, this one is equal to 20 ohms, let's say, and we have another resistor. Let's say this is equal to 30 ohms. So in this case, the R total, for example, it has to be greater than the greatest resistor. R greatest means the largest. It has to be greater than that. This is very simple thing. We need to be very clear about this one. The second thing for parallel circuit, you also need to understand if we have circuit and we have these resistors. Let's say we connect them in parallel. So if we connect them like this, let's say we have these few resistors, they are connected in parallel. Let's say this R1, I can say this is equal to 5 ohms. Let's say we have R2, this is equal to 10 ohms. And we have R, let's say this is equal to 15 ohms, this one. Now in this case, if we need to find R total, we need to be very clear. It has to be smaller than R smallest. So this is very useful because physics board exam is about timing, how quickly you can answer. So if these things you have in your mind, you can go very fast and you can answer very quickly. So you have to be clear about that. Okay, one thing more we need to understand about this parallel circuit is that if let's say we have this circuit again, so I will write down here circuit for you. So let's say this is R and this is also R. They are identical resistors. Let's say we connect them. These are identical resistors. If we connect them in parallel, all of them, they are identical, mean they have the same resistance. So in this case, R total, for example, you no need to do a lot of mathematics. Simply what you need to do is you need to take the resistance of one resistor. You have to divide by number of resistors. So if you do this one, you will find the total resistance. But condition is that these resistors must be identical. So this is the important point. You have to be very clear about this. Okay, so this was just kind of quick review about these two types of circuits. The next one we call is complex circuits. Complex circuit. So I just want to highlight few points. So okay, complex circuit. So complex circuit, for example, we can solve them by two different laws. We can solve them. First one we call is Kirchhoff's First Law. So this law is very helpful. Kirchhoff's law, you can say, or rule, you can say first actually. So this is first one. Kirchhoff's First Law is simply telling us that if we have circuit like this, let's say, let me draw this parallel circuit for you. So if we have this circuit, let's say current I is coming at this junction. This point is called junction actually. And it's split into two parts. You can see I1 and I2. So this law simply tells you is that at any junction. So simply we can say that at any junction. So you can see at any junction I entering has to be equal to I leaving. So the I entering has to be equal to I leaving. So this is a thing you need to understand. Means the amount of current entering has to be equal to amount of current leaving. So we can say I entering has to be equal to I leaving. So this is, you have to understand. If you are very clear about this, that's very nice. If not, so this is important thing you have to keep in your mind. So the second law, Kirchhoff's second law or second rule, you can say, I'm just writing here Kirchhoff's second law. This law is very handy, very powerful to answer a lot of questions. So what this law is telling us, this law is simply telling us, if you have a circuit like this, let's say we have resistor attached here. Let's say this resistor is R1 and we attach another resistor here. Let's say this resistor is R2. So according to this law, let's say this is voltage V. So this law is telling us that in any loop, so loop, what does it mean? Loop means that this closed figure, this one you see, this closed shape, this is called loop. In any loop, delta V has to be 0. Very simple but very powerful rule we have to understand. Simply it means that if I start from here, I go in this direction like this, and if I come back to the same point, delta V will be 0, because at one point potential is the same, so it has to be 0. So in any loop this is applied. If you apply in any loop, we can take this loop or you can take this loop. This is also one loop. Or if you start from here, you go this way and you come back to this point. So again, delta V has to be 0. So we have to be very clear about this point as well. Okay. So, and also for example, so one thing more we need to understand is that, let's say, if I have this circuit, I will draw again for you so you can see it little bit in a proper way. So this is a big circuit here now. So we can draw like this. Okay, according to this actually, now let's say, if you cross a power supply, there are few things you need to understand. I just want to highlight so you guys all has to be very clear about this. Otherwise you will get confused. So one side I will write battery, on other side I'm writing for resistors, mean consumer of electricity. So for battery, for example, if we go from negative to positive, if you go in this direction, so you have to take V positive, means you will gain voltage, you have to take positive. And if we go in the opposite direction, let's say if you go from positive to negative, so we will take V negative because we will lose voltage in this case. And for resistor, we also need to understand. Let's say, let me ask you first of all one question. Let's say this is a 10 volt battery. So if I cross from here, what is potential at this point? So you will simply say this is 10 volt in direction of current. But how about potential here? So this has to be 0. So if you go in direction of current, so let's say this is resistor. So we need to understand this is resistor. If current is flowing in this direction, so in this case V we will take, that will be negative, because if you go in direction of current you will lose voltage, so we will take negative. So this is one case. The second case is that if we have this resistor, if current is flowing from left to the right, and if we go this way, and in this case we will gain voltage, we will go from low voltage to high voltage, so we will take V has to be plus. So these are basic things I think most of you have studied. If any one of you is not clear about these points, so please just let me know. If you understood this one, wonderful. We can go to next. So any questions until now? Okay, so if this is clear to you, I will clean this one and write some more points for you. Okay, excellent. Excellent. So let me write down some more points for you. So there are a few more points we need to understand because you are from two different classes. So in order to bring you together, we have to cover all the points. So here, let me write down here for you. Okay, good. Okay, next thing. Okay, here, next what we need to understand is, we need to understand about internal resistance. Let's say we have a circuit here. We are talking about real battery now, real battery. So when I say real battery, this term also you need to understand. Real battery means that battery has internal resistance. So you have to understand it has internal resistance. Means some of the voltage is lost inside battery. So the real battery here, if you have a real battery, it has its own internal resistance. So here we have load. So we can connect this circuit like this. So this is a battery. So actually, if you look at this one, why I draw like that? This is your battery actually. This is a battery. So this is the positive terminal of the battery and this is the negative terminal. So this is the EMF of the battery and this small r we will use for internal resistance. Okay, so this is resistance of source itself. So we call internal resistance. So we also have another name for this one. So you also need to understand the language. We can also call this one source resistance. So we can also simply say this is source resistance. So R. And this R is a capital R. So this is what we call is load resistor. So you need to understand this is called load resistor. Okay. Okay, so listen please. This is called load resistor. So now we need to understand if we attach voltmeter here, if we attach voltmeter at this point, let's say attach voltmeter here across this resistor like this, and if I attach voltmeter like this here, like this from these 2 points, so you will simply say that in this case EMF will not be equal to V, will not be equal to V. Why? Because some voltage is lost here. So you will say EMF in this case is greater than V. Okay, because there is internal resistance. And this V actually, and this point, this V, we give a special name to this one. So this V is called terminal potential difference. Why it is called terminal potential difference? Because you are connecting across the terminals of the battery. This is positive terminal, this is negative terminal. So we call this is terminal potential difference. So we call terminal PD, or we can say VT here. So this is terminal potential difference. And if we write equation for this one based on by conservation of energy, we can also write down like that. Let's say current I is flowing in this circuit. I is the current. So we will say E is equal to I times capital R plus I times small r. Okay, so this also we can write down in a little different form. We can write down like this. Okay, so this is called terminal potential difference. So this is IR is terminal PD, and this term you see here, this is called volts lost, or lost volts, you can say volts lost. Means this much many voltages are lost inside battery due to its own resistance. So we can write down this formula like that. We can say is equal to VT plus we say V lost. So this is, we can write down like this. And this formula we can also rearrange. If we write down in this form, we can say VT and we can say E minus I times R. And again we can rearrange this one. We can say this is minus R times I plus EMF. Now if I need to sketch a graph, for example, so you need to understand, if we sketch a graph between V on y-axis and I on x-axis, so you need to understand, if I is equal to 0, let's say this become 0, let's say this is equal to 0, so VT has to be equal to this much. So it means it has to start from here. So, and then it has to follow straight line, because this is the gradient actually. If you compare this one with straight line equation, y is equal to mx plus c. So this is actually the y-intercept, and this one is the gradient. R is the gradient, I is x variable. So in this case the gradient is equal to minus R. So you need to understand there can be one multiple choice question about this one. What is gradient of V against I? So it is equal to minus R. So this is how we can calculate. Okay. Okay, so any question about this until now? So is it okay? So can we move on to next one? Okay, so let me clean this side. Let me write some points for it. Now here's just few more points. We will finish very quickly. Okay, next one please you need to understand is that if I have this circuit, you have to understand about this circuit something more actually. So that's the reason I want to redraw this circuit to emphasize the point you need to understand. So this is resistor, load resistor, and this is the internal resistance. This load resistor, for example, it can be a resistor, it can be a speaker, it can be bulb, it can be anything. So this is load. Load means the consumer of electricity. Now the thing you need to understand about this one is that if I need to sketch a graph, for example, the power delivered to this resistor, power delivered to this resistor, unit of power is watt, and this is the resistance, load resistance. So for this one you need to understand, if we sketch a graph, so we see something like that. You will see something like this. This point is very important to understand. I have seen in a physics board, often they ask about this question. It's a kind of typical question, so you have to understand typical question. So at this, the P is the maximum, so I will simply write like this. So P is maximum at this point. So what is that? What is this value of resistance? And this value is when capital R is equal to small r. So you can see when this load resistor, its resistance is equal to internal resistance, the maximum power is delivered to this one. If we increase this one more, the power will go down. Why it will go down? Because if current is high, more energy is wasted here. So this is kind of optimum point. So at this point, when capital R is equal to small r, the power delivered to this resistor is maximum. So we can also prove this one. So let me give you some values. Let's say EMF of this battery, if you're not clear why like that, so let me give you some numbers to show you it is true or not. Let's say EMF is equal to 12 volt, and this resistor, let's say, is equal to 2 ohms. And this resistor, let's say this is a variable resistor, means its resistance you can change. Let's say we change its resistance from 0.5 to 4, or any number you can choose, is no problem. So now let's try to find the P max. So the P max, for example, when you need to find out, so we remember the simple formula for power is I square R. Means we're talking about the power dissipated in this resistor. So we have to use capital R and current in this circuit. So how we can find I? So I, simply you can find out the EMF of the battery divided by total resistance. So we can rearrange like this, and you have to multiply by R. So I will just draw 3 different columns to show you this is true. So we can simply do like this. Let's say when R is equal to 0.5 ohms, this R. So we can write down in this case P max. Okay, P max has to be 18. Excellent, that's true. I just want to show you 2 more numbers. P max has to be 18. If it is equal to it has to be 18. So just look at this one. So you can just plug in values. So this is 12, and you have 0.5 plus 2. And if you solve this one, multiplied by 0.5, you will get about 11.8 or 6, something around about this one. So you can just check the exact number if this is true. Okay, and if you use R is equal to 0. R is equal to 2, just do quickly. If you use R is equal to 2 actually, so if you find P max, you will get 18 watts. This is the maximum. And if you use R is equal to 4 ohms, you can plug in this formula. You will get P max. You will be about 16 watts. So you can plug in any number. You can test this one. You will get the maximum value when this R is equal to 2 ohms. So this is very important point. If you keep this in your mind, you will look at the question and you will be able to answer. Okay, so this is we need to understand, and I hope this is clear to you. So we can go to next now. Okay, so this is important. You need to understand this point. Okay, so let's go to next one now. Okay, now here please. This is a question for you. Spend some time and try to find out the answer. Okay, so try to answer this one. So you can follow one direction actually, so it will be easy for you. Let's say you can just follow clockwise. You can take loop clockwise, so it will be easy for you a little bit. Or anti-clockwise is no problem. EMF is given here. This is 4 volt and 6 volts. Okay, let me check actually if this is the right answer or not. Okay, just 1 minute. It has to be this one, please. The third one actually. So maybe you need to recheck. So if here, this is valid. If this one, we can verify this one. Is 5, we can check actually. We can check for different loops. So check the third one for the left loop. Here for left loop, check this one. Okay, so just 1 minute. So let me explain to you why this has to be true. So just 1 minute, let me explain why this has to be true. Okay, so you can see here, for example, this is loop, other you can check by yourself. So I will just prove this one that this is right actually. So let me here. So this is means we are talking about this loop. It direction doesn't matter which way you go, you will get the same answer. Okay, now in this loop, if I start from this point, if we start from here, I go this way. So you can see I'm just talking about this loop now. Other loop you can try by yourself. So let me first show this one. If I go from negative to positive, I will gain voltage. So we will say the V has to be plus. We can say this is 2. Now if you go in direction of current, you will lose voltage, mean high voltage to low voltage. So this one will be minus I1. Because resistance is 1, so if you multiply by 1, you will get 1, I1. Now if we go here, again here, from positive to negative, we will lose voltage. So this is 4V, so just you can write down V, or you just all voltage you no need to write down. And if you again go in direction of current, so this is 2, and you see this is I2. So and again, if I come back to this one, delta V has to be 0. So this is true. Other one, rest of the equation you can check. So this is true. So that's reason answer is this one. So is this point is clear? Okay, so the 4 points I taught you at the beginning, you have to keep those 4 points in your mind. Then you can figure out. Okay, so is this one is okay? Okay, if this is clear, so let's go to next one. Okay, now here please, you can see here now this setup. You can see this setup now. And this setup, what we call is called Wheatstone Bridge actually. This is very useful actually. Okay, why the voltage is negative but don't change? This is a very fundamental point. So let me go back and tell you why it is not. So let me just go back and check here. Now this one please you need to understand is that we are not talking about direction actually. This is the point. you need to understand, for example, I have explained to you at the beginning of the class when we talk about battery. So here is a battery. There are two things you need to understand. One is about battery, one is about resistor. So for battery, for example, if this is our battery, so this is a positive terminal, this is negative. If you go from negative to positive, you will gain voltage. So the V has to be plus. And if you go, for example, from positive to negative, so you are losing voltage. You are moving from high potential to low potential. So this has to be negative. Is this point is clear? So this is one thing. For resistor, you need to understand, if this is a circuit, let me draw a very simple circuit for you. So let's say we have just one resistor and one cell. So this end, if this is 8 volt, EMF is equal to 8 volt. So I can simply say that I will say this side is 8 volt and this is 0 volt. So what is potential at this point? We will say this is 8 volt. How about potential here? It also 8. How about potential here? This is also 8. But when you cross this resistor, potential here will be 0. So it means if you go in direction of current like this, voltage drop means you go from high potential to low potential. So that's reason if you go in direction of current, so if current is flowing this way, let's say this is I, so in this case V will be negative, minus. So if you go in the opposite direction, for example, if you cross from this side to this side, you are in opposite direction of current, the voltage will increase, means you go from low potential to high potential. So we will say the second thing you need to understand is, if you go, this current is flowing this way, this is I. If you go this opposite, V you have to take plus. So that's reason. So if you go across this one, you go, this is the direction we followed, this one. So this is counterclockwise. Okay, you can also do clockwise, the result will be the same. So here was positive, here was negative, here was negative, here also negative. So that's reason we choose this answer. So this is because this I2 actually is all together, we are talking about this current. So that's you, in this case you can take only one. This I2 is determined based on whole circuit. So this is not only determined due to this one. I2 is determined based on whole circuit. So based on whole circuit. So you no need to then worry about other part because its effect is here. So that's reason we no need to worry about right loop. Effect is already here. So that's reason. Is this point is clear? So that's reason you no need to worry about right actually, because effect is already there. So this I2 is based on this one as well. Okay, so when we find I, we will take these two loops together. We will take the whole circuit. So effect is there. Okay, so that's reason. Okay, I hope it is clear to you. So this is these 4 points you need to understand, and any direction you can take, doesn't matter. As long as you are means you have to be consistent, that's all. Okay, so let's go to next now. Okay, here please. Now here again you need to understand. So we were talking about, this is called Wheatstone Bridge actually. It's a very practical thing actually. So what is use of this one? Now you can see we have single battery and we have 4 actually resistors. Let's say this resistor is known. We have resistance of this one is given to us. Let's say we have another resistor. This is also known. We have this one. Let's say this is unknown. You have to find, and this resistor is a variable resistor. With this one we can change the resistance. So by changing resistance of this one, we can find resistance of this unknown resistor. So this is a way to find resistance of unknown resistor. So with this setup we can find out. So let me little explain to you the principle behind this one. So let's say this is a positive terminal, so it means current will flow in this direction. So at this point, according to Kirchhoff First Law, I will split into two parts. So let's say this one is I1 and this one, let's say, is equal to I2. Now this is galvanometer, so we have to find the balance point. So we need to find the balance point. When I say the balance point means that I through this one, I will say balance point means Ig is 0. This is 0. So this is we call is a balance point. So and this is purpose of this variable resistor to adjust the resistance of this one until there is no current in this branch. No current. It means the potential here is equal to potential here. So when Ig becomes 0, it means your Wheatstone bridge is balanced. So when it is balanced, then we can find out this one. So how we can find out this one? When this is balanced, no current will flow this side. So I can give number to this one. I can say this is I2. This current is I2. This is I2. So we can just change number. I'm saying this one is I3 because this is I2 I wrote here. So you can I can give different numbers. I can give this is R2 and this is R3, so you don't get confused with numbers. And this one I can also say this is I4. I will give number to this one I4. Now one thing you need to understand is that if no current goes this way, then I1 has to be equal to I3. So I will say that then I1 has to be equal to I3. Okay, so this is what you need to understand. And the second thing you need to understand is that if no current goes this way, means to the left, I2 has to be equal to I4. So I will write down I2 has to be equal to I4. Okay, now the next point you need to understand is that now we take one loop now. Let's say we take this loop now. I will start from here now. So this is kind of revision of Kirchhoff's second and first law for you. So it's a second chance for you to understand this one. If I go from here, I go in this direction. So like this. Then I go this one. So this is over one loop. So this is one loop. So you can see this is one loop. So loop is A, D, B, A. So I will write down here we have loop A, D, B, A. So I'm talking about this loop now. So in this loop you can see if you go in direction of current, so you will lose voltage. So I will say this is minus I1 R1. And if you go in opposite direction of current, so we will say it has to be plus, we will gain voltage. So we will write down this one. Is this clear? So we just simply write down. So other way you can also write down is I2 R2 has to be equal to I1 R1. So from here we can rearrange. We can say that I2 over I1 has to be equal to R1 over R2. This can be done very quickly, but I just want you to have little better understanding. So we got this one. No, this is Ig actually. So this Ig, this is not I4 actually. So this is Ig. So you have to find the balance point, then you can determine this one. So this is condition to find the balance point. Otherwise you cannot then find this resistance. So we have to find, this is the purpose of, yes, here. So this is a balance point. You have to balance this one. So when Wheatstone Bridge you balance, then you can determine this one. So this is condition for Wheatstone Bridge. It has to be balanced. So this is condition. So I can write here for you. So this is condition. So it has to be balanced. Otherwise you cannot find this one then. Okay. So that's reason it has to be balanced. Okay, so we are talking about when it is balanced, the balance point. So balance point means Ig is equal to 0. So now we can take the second loop now. So the second loop is this one. We can start from here. So let's say we follow this one here again. So we go this way. So this loop is, we follow, this is one loop. You see, it's closed. Okay, so in this case, if I go in direction of current, I'm talking about second loop now. Now we are talking about D, so we will write down D, C, B, D. So we are talking about this loop now. So here we can simply say, so this is in direction, so I will write minus for this one. And this is opposite direction, so we can say that that is Rx times I4. This has to be equal to 0. So now we can rearrange, we can write down like this. So this is equal to Rx and this is I4. So you can see here. Now a little bit rearrange, we can write down in this form. So we will get Rx over R3. This one here, we will get this. Okay, now we have equation 1 here and we have 2 here. Now you can see here. So now this one you can see. So I1 is equal to I3 here. So you can see I1 is equal to I3. So you can take 1 and you can rearrange that. I2 is equal to I4. So we can rearrange this one to see what's going on. We can also write down like this. So I4 for example. So we can rearrange. We can say this is I4 over I3. We can write down like this. Okay, I4. So now if I write down in this form, so from here, if you wanna see little clear, so you can go back because I want you to see the relation between these two. So we can go to this one. We can write down. So from here you can see we have I4 divided by I3. So you will get this is R3 by Rx. So you can look at this one now. Here please. So you can look at this one now. So you see I1 is equal to I2. So I1 here you see I1, this is equal to I3. So it means this one, if I write here, this is I4 divided by I3, this is equal to R3 by Rx. So I3 you can see from here, this is, so this is equal to I1. So I can write down this is equal to I1. I4 is equal to I2. I can write down this is I2. Now you can see here, if you look at this one and this one, can you see this side and this side, they are equal. So simply we can say that R3 by Rx is equal to R1 by R2 here. So this is a formula we can figure out from here. Now if you need to find Rx, so Rx will be equal to by R1. So with this one you can find value of unknown resistor just following these steps. Maybe this is quite long to derive this one, but you can find out the relationship. You can see here. Yes, R1 by R3. So you can see here R1, R2, the ratio, and this is equal to this ratio. So then this is what you need to understand. Okay, so this is how we can derive, and also this is practice for you, how to use Kirchhoff First Law and Second Law. So you can follow these steps and you can derive this one. Okay, so this is the main thing we have to understand. So you see the ratio between these two. You see R1 and R2. You can see this is R1 and this is R2. The ratio between R1 and R2 has to be equal to the same ratio between this one and this one. It's a very useful. You can see from here like this and here. So this ratio is very handy. You can it's very helpful. You don't need to derive then. For physics bowl, if you just remember this one, that's quite enough. You don't need to derive everything. Just to prove how we can get this one. Okay, so is this point is okay? Okay, so this is ratio. This is how you can find out. Okay, so let's do some questions now. So we will little practice, we will answer some questions and then we go to next topic. Okay, so this is you can write in different ways as you can write in different ways. This one R3, so it will be Rx by R2. So you can write in different form, but this is one way, easy way to remember is this one. You see the ratio between these two has to be equal to ratio between these two. You can also do like this, but this is one way. Okay, so let's move on to next one. Okay, so this one please. This is one simple point. Just look at this question now. So this one you can see, this is a straightforward question. Actually by mistake, answer is shown here. I'm not sure this is right or wrong, but you can check out. Maybe you get different answer than me. So just check. What is the answer? Is this is right answer? I'm not sure actually. I didn't check this one. So this is quite straightforward, you have to understand, because this resistor all are identical resistor. So the potential here has to be equal to potential here. Automatically it has to be balanced. Because no potential difference, no current will flow. So the reading on this one has to be equal to this. Okay, so is this one is okay? What answer? Okay, excellent. So if you got this point, excellent. Let's move on to next. Excellent. It has to be 5 because identical resistors. So potential here is the same potential here. No potential difference, no current flow. Okay, so this is the point you need to understand. Okay, here now, look at this one now. Let's try to answer this one now. Try this one. Okay, so what is answer for this one? Okay, just type your answer. Okay, excellent. It has to be 5. So why it has to be 5? So if some students not clear, let me highlight that one to you. So this is 0 actually. So this is 12. So potential here is also 12. If for here, this is 0 and across this one, this is also 12. So again, you can find out. So you see these 2 points are at the same potential. So it doesn't matter this switch is open. It doesn't matter this switch is closed. No current will flow. So it means nothing will change. So this is, you need to understand. Okay, this is. Okay, so nothing will change in this case. Here, now let's do some question from past papers. So we will do question from physics bowl now. So let's do this question. So you just need to tell A, B, C, D. So what is your answer? Read question, answer. If not clear, I will explain. Okay, read question and answer. Okay, check again. Actually, it doesn't. It will change actually. Check again. A shouldn't be the answer. So check again. This is removed. So this is removed now. If I remove this branch actually, so tell me one thing, R total will increase or decrease? So if you said R total will increase, that is right. If R total will increase, so how about, okay, let me just check. R total increase, I will go down. So it means the resistance, a power of this one here. So you can say power is like this, I square R. For example, if I go down, this has to go down. So its brightness has to decrease. So D is also not answer. I goes down, P go down. Okay, let's check answer. It should be E actually. Okay, this one please. It should be E. The reason, now look at this one now. When you cut this branch actually, the total resistance will increase. Total resistance increase, I will decrease. I will decrease. When I will decrease, so it means the power of this one will decrease, but power of this one will increase. Because I through this one will increase. So the answer should be E. So this is how you can figure out. So this is one thing you have to understand, then you can figure out. Okay, so let's move on to next one. You have a lot of practice. We have prepared question for you topic wise. So you will do that one after class, then you will ask more questions. So let's move on to next one. Okay, let's try this one now. Okay, this one please, try this. Okay, this one please, try now this question. So the best way is draw the circuit. I just want to draw circuit so we can save little bit time. So I will draw a circuit for you like this. Okay, so what is answer, please? What is your answer? Can you tell me your answer? Okay, so please let me know what is your answer. Okay, so let's see what you have got, but okay, so this is right. So you can see here I have also written some points for you. So this one was brighter when it was connected in series. It means its resistance was greater because I is the same. So I just wrote some points for you. So I was same. So the power is equal to I square R. So this one was brighter. Okay, so the answer actually has to be E, for example, for this one. And in this case, now you can see here, so V is the same. So this one has higher resistance, so current will be lower. If Rx is greater, so the current through this one will be lower, so current of that one will be lower. So the power you can find out V times I. So here, okay, so this will be brighter, but Y will be more brighter now because V is the same, but I, so we can say IY is greater than IX now. So this is how you can answer. So this is how you can choose answer E. So these points you need to understand. So I have written here for you. So this is what you need to understand. So is it clear? So is this question is okay? Okay, so this is how you can figure out answer. Okay, so shall we go to next one? Okay, if this is clear, so let's go to next one now. Okay, here please. This is simple question. So try to answer this one now. Just type your answer. When you figure out your answer, just type the letter. Okay, okay, so I'll check this one, please. For example, they're identical resistor now. So it means you can replace them with just one resistor. So you can replace them with 10 ohm. Then you can add. That's all. Excellent. So this is simply you can answer. So this is right answer. C is right answer. So C is right answer. Excellent. So let's move on to next one now. So maybe this question will challenge you a little bit. So try to answer this now. So the language of question is very important. Read question and try to answer now. check again, there is answer. E is not. E is not. Okay, is not, so is not answer actually. There is another answer. Not is not right answer. Excellent. A has to be the answer. So let me explain to you. A is right answer. When the resistance of the variable resistor is increased, when you increase this one, so we can draw this circuit again like this. So no, C is not actually. So let me explain to you this one now. So you need to understand, if we have, this is a load resistor, we can little draw this circuit like this, you can see. Now if you increase this R, for example, if you increase this one, this is R, so this has internal resistance, you can redraw circuit like this. Redraw circuit like this. So the answer is actually for this one should be A. So this should be the answer. So now how we can understand this one? So simple, you need to understand this is EMF and this is R and this is total R. So the potential difference actually, if you have only one load resistor, so the potential difference here, this one please. So this is we call terminal potential difference. If you remember at the beginning of the class, I explained to you we call terminal potential difference. This is the same if you attach your voltmeter across this cell, across this one, because this is your battery actually. So it is, this one is battery, this is, so this is the positive end. So the potential difference here greater. But when you increase this R, the variable resistor is increased. Which of the following statement is true? When you increase the resistance, let's say you are starting from some value, so the potential difference across this one will increase. Okay, when the resistor, so the potential difference here will increase. Okay, so this is what we need to understand. So EMF, you can also understand Vt plus V lost here. Okay, so this is. Okay, let's go to next one. So if this is clear. Okay, here please. Now try this one, little different question. So try this one please. Okay, so this one please, this is, it shouldn't take too long. So D, okay, excellent. So I will, okay, so let me check first of all answer. So excellent, answer is D actually. So simply you can write down, if some students are still struggling, so you can write down Q in terms of number of electrons. So I can say N small q is the charge on single electron. So then simply what you need to do is I is given to you, T is given to you, Q is the charge on single electron, and this is charge on single electron. So just plug in number and you will get your answer. So the answer in this case is D. So you just need to write this total charge in terms of charge on single electron multiplied by number of electrons. So then you can get your answer. So this is how you can work out. Okay, here now. So here, now try this one. Okay, please, when you finish, just type your answer. Excellent. Answer should be A. Excellent. It has to be A because very simple way. For example, you see the resistance almost same. So we can, excellent, it has to be A. So we can simply say it has to be I square R. I is square actually. So it's a big part by I. So this has the maximum current here, the total current through this one. So it has to be A. That's all. Okay, so answer has to be A for this one. So P is equal to I square R, so we can find out. Okay, so this is how you can answer. Okay, try to answer this one now. We are asking this question in a different way now. So try now. You have the same circuit. No, please check again. It shouldn't be 1. So check again. It shouldn't be 1. So first of all, please, you have to find here. So you can replace this one with one single resistor. So we can replace this one. Excellent. It is actually 0.4. So how you can answer this one? It has to be 0.4. So you can, excellent. It has to be 0.4. So what you need to do is you have to, these two resistor, you can see, you have to replace with one resistor. So just parallel you can find out. So if you solve this one, you will get, this is 20 ohms. 20 ohms. So you will get 20 ohms. So this is 50. So you have another circuit now. So you can find the total resistance, then you can find current and you can figure out. So I will just write down the main idea for you. So we have one resistor here. Then you have an other resistor here. So this resistor is 50 ohms and this resistor is also 50 ohms. So this is also 50 ohms. And this one R1, this is equal to this is also 50 ohms. So we can also draw another circuit for this one. So you will get, this is 50, and here you will get another resistor that is equal to R1. This is equal to 50, and here R will be equal to 25 because they are in parallel. So then you can find I. So you can find I total. So that will be equal to 3 divided by 75, and then you can figure out. Okay, so this one please. So you have to find I total. So when you have I total, half of the current will go this way, half of the current will go this way, and then you can find the potential difference. You can figure out then. The potential across this one has to be equal to this one. Then you can work out. I hope you are quite smart student and it's not a big deal for you. So this is how you can work out. So if you work out, your answer will be this one. So this will be our final answer. So this is how you can work out. So this circuit is important to understand. Equal. I here is the same. Then potential here is the same here. We can find out. Okay, so let's try some more questions here now. So here is another question for you. So please read and try to answer this. So for this kind of question, you have to draw the circuit. It's very good to draw a circuit. I just draw bulb actually, light bulbs here. R resistors, no difference. Check again please. It has to be E, excellent. It has to be E. So here please. So R total in this case, R by 2 here. So how many times this resistance is greater? This resistance is greater than this one 4 times. So it means that current here, I can say this is circuit 1, this is circuit 2. Otherwise I can say that I parallel has to be greater than I series. How many times? So I parallel has to be equal to 4 times of I series. So 4 times in I series there was 2, so you forgot to multiply, so that has to be 8 amps. So this is our answer in for this one. Okay, so this is please. Okay. Okay, so how many minutes we left? We just left few minutes. So let me explain you. This is we have discussed about DC circuits. So next we will talk about electric field and all those things. So let me highlight some key points for you. So we can, next class we can start from here. Otherwise I can ask you some question to see how much you know about electric field. Then I will explain the key points. So let me ask you some questions first of all. So can you try to answer this one? So just try a few questions, and at the beginning of next class I will explain you all key points, then we will do questions. So here try to answer this. We can draw like this. This will be more easy to understand, like this. and this is the separation between plates is given. D is the separation. So what we did actually, this battery had this voltage V. So what next we did is that we have these two plates here and we disconnect battery like this one. We disconnect battery. Now what you need to understand is that what will stay same. So what will stay same? So I will write down, you need to think about this one. What will stay same? Is it V will stay same? Is Q will stay same? So when we disconnect battery, so what will stay same? And then you have to understand a little about this formula as well. Is not. Little think about more about this one. You also need to understand when you pull these plates apart, you will do work actually. The work done by you actually will be stored in form of energy actually. So Q will stay same. So here Q will stay same. So this will stay same. Charge will not go anywhere. So this will stay same. Now we need to have a look at capacitor. Okay, excellent. So it has to be, so we need to look at capacitor now. So capacitor is equal to epsilon A over D. Actually, we will discuss these concepts in next class. So when the D increase actually, so the C will go down. If this go down actually, V has to go up. So the V has to go up. This one please. So you need to understand V will go up. Why the potential will increase? Because when you will pull these plates apart, you have to do work actually. So when you did work actually, this is done against electric field. So work done will be stored in form of electrical energy. So the voltage will go higher. Simply you can understand. This is one way. Otherwise you can also understand with the help of this formula. So the voltage will go up. Okay, so that's all. At the beginning of next class, I will explain all these points to you. If you are not clear about capacitor, capacitance, and we will discuss at the beginning of next class, and then we will do questions.